over 2 is going to become a what? A 6. You can do that already in your head. And tell me that answer, so that'll be what I write, okay? So now we're plugging in 0 and what? 4. So we're going to get 4 is equal to 0 plus 0 plus c. So we know c is what? 4. So my first derivative equation is 6x squared plus 6x plus 4. All right. Integrate again. Boom, boom. F of x is equal to 6x to the third divided by 3.
2x cubed.
2x cubed. 6x squared divided by 2. 3x squared
Plus 4.
plus 4x
Plus
plus.
is equal to negative.
Okay. And we're going to plug in 1, and my answer should be negative 2, right? So that's going to be 2 times 1 to the third plus 3 times 1 to the second plus 4 times 1 plus c. So just add the coefficients. 2 plus 3 plus 4. That's 9, right?
Yeah.
So we're going to minus 9, right? So we get c is what? Negative 11. And what's my original equation? 2x to the third plus 3x squared plus 4x. Too easy, Anthony? Yeah? Alright. We should put some trig in there. There'll be some with trig on your assignment. Don't worry. How about 7? Or you had enough? You want me to do it? Okay. So let's do 7 here. Okay? Integrate and integrate. So we get the first derivative is equal to what? What are we adding to this exponent? 2 over 2. So that gives us x to the what? Negative half, and we're dividing by negative half, which is really like multiplying by negative 2, right? Okay? That was easy. Plus what? Plus c. What do we know that x to the negative half is going to go? It's going to go in the denominator, and it's really just the what of x? Square root of x, right? Okay. So we're going to get 2 is equal to negative 2 divided by the square root of what? 4 plus c. What's the square root of 4 or 7? 2. Negative 2 divided by 2? Negative 1 plus 1. So c equals 3, right? So my first derivative equation is going to be negative 2x to the negative half plus 3. And it's better that you leave it like that with the negative power, Natalia. So that way, when you add the 2 over 2, it becomes equal. So again, one more time. Integrate and integrate. So we get f of x is equal to negative 4 x to the positive half.
Yeah.
Right, we're going to end up with negative 2x to the half divided by half, which is really times 2, so negative 4. Very good.
What?
Plus 3x
Yeah, you get
plus c. And now we're ready to substitute 0 and 0, right? Okay. So if I put 0, what do we end up with? 0 plus 0 plus c. So c is 0. So my original function is negative 4 square root of x plus 3x plus
You don't have to put anything.
plus nothing. Just kidding. I was just copying that. Good? Too easy? You got it? Ready for the assignment? Or you want some more examples, like some application problems? Problems where you gotta think a little bit before just, getting the answer.
Can we go on with trig?
Can we do one with trig? I don't have any with trig as examples, but there is one on your assignment which is pretty easy. It should be okay. But I do want to do these application problems, because these are going to mess with your mind.
They had no choice.
Yeah, basically.
They're so much fun.
Wait, so you weren't messing with our minds before?
I wasn't messing with your mind yet. Right now we're gonna do derivatives and integration, and it's gonna like. It'll be like, oh my god, I don't even remember how to find a derivative.
This is our quiz. I don't even remember how to tell
This is
my
our
quiz.
We're gonna do some related rates because we haven't done those in a while. You remember related rates?
Unfortunately.
Find when given equation? Wiggy. Remember when we used to get wiggy with it?
That's the only reason I remember it.
Not jiggy with it, okay? Wiggy with it. Alright, here we go. Robert, will you read this to us since you read so nicely?
Evergreen nursery usually sells a certain shrub after 6 years of growth and shaping.
Oh my god, 6 years before they sell it? That's crazy, man. When are you gonna make money?
The growth rate during these 6 years is approximated by the differential equation. dH dt is equal to 1.5 t plus 5, where t is the time in years and h is the height in centimeters. The seedlings are 12 centimeters tall when planted at t equals 0.
Okay, great. Okay, so this equation represents h or h prime or h double prime. What does it represent?
Right.
H prime, right? It's a rate of change. So it's describing what? What is this rate? What is this describing? The rate at which what? The rate at which the
Shrub grows.
the height
The height of the shrub.
of the shrub
Is increasing.
changes, right? Increasing or
Decreasing.
decreasing, right? We hope it always increases, right? We don't want the shrub to shrink. How could it shrink? I don't know. Maybe it would just stay the same, right? They never watered it,
And
and then it starts shrinking. What else do we know? The seedlings are what? 12 centimeters tall when planted at t equals 0, right? So like the starting height from when they start using this equation to represent the rate at which it's growing, okay, initially the height of those seedlings are 12 centimeters. That's good information to know. All right, let's look at the first question. It says, find the value of the differential equation above when t equals 3. Using correct units of measure, explain what this value represents in the context of the problem. So what do they want me to do with that 3? Just plug it into that differential equation. So let's do that. So we're going to find dH dt when we plug in 3. So that would be 1.5 times 3 plus 5. Let's see if we can do that without a calculator.
1.5.
1.5 times 3 is what?
4.5.
4.5 plus 5, we get
9.5.
9.5. And what would the units be? Centimeters per year or year per centimeter?
Year per
Year per
centimeter.
centimeter.
Year per centimeter squared?
Yeah.
An
Yeah?
alternate universe, yes.
No, centimeters per year. Okay, so what would this be describing about the height? What is it telling us about the height? We need to write the interpretation.
After 3 years, it is.
Could we just say at
So after
t equals 3? What's happening?
the rate at
The
which
height
the rate at which the
is-
height is
increasing at a rate of 9.5 centimeters per year. That's it. That's the simplest statement that you have to write to describe it. Okay? Everybody should be able to do that. Not on average, okay, not for the first 3 years. It's at exactly what? 3 years, right? At exactly t equals 3, the height is increasing at that rate. What if it were negative 9.5? How would we change the statement?
It's decreasing.
Decreasing at a rate of 9.5 or negative 9.5? That's what some of you did on your test. But decreasing at a rate of negative 9.5 centimeters per year. Why don't we put the negative and decreasing? It's redundant, right? It's like saying that it wasn't decreasing. Right? You're decreasing at a negative rate. So technically you're increasing. Yeah. So you gotta be careful, okay? Alright, very good. Alright, let's look at part B. Part B says, find an equation for h of t, the height of the shrubs at any year t. They want us to find the original equation h, but they're giving us h prime. So how would we do that? How do we solve a differential equation? How can I make this dh dt equals 1.5 t plus 5 h equals? Multiply by dt. So now I have dh is equal to 1.5 t plus 5 dt. And then we integrate both sides. When I integrate the left side, I get just what?
H of t.
H of t, or h, is equal to what?
3/4 t squared plus 5t plus.
So what most people would find out, Pablo, is 1.5 t what?
Squared.
Squared over 2, which is, like you said, 3/4, plus what?
5t
5t
plus.
plus c. But that's not the equation of the height that I could use at any time t. That's a generic equation. I need a specific equation for the height. So I need a point. What's the point? 0.12? Where'd you get 0.12? They gave it to us at the beginning, right? Okay, so we know we had this point 0.12. At time t equals 0, the height is 12. Okay, so if I plug in 0 here and 0 here and it equals 12, what is c gonna do?
12.
12. Do I need to show that work or you're okay? I can show it if you want to. 0 plus 0 plus c. Yeah?
There you go.
There you go. So what's my specific height function? 3/4
T squared
t squared
plus 5t plus 12.
plus 5t plus 12. Okay, and then they want us to evaluate, and it says, then determine how tall the shrubs were when they were sold.
So put 6.
So we plug in 6 because they sell them after what? 6 years of waiting patiently and watering. I wonder if they even make any money. So 3/4 times 6 squared plus 5 times 6 plus 12. Oh my God, without a calculator, how am I going to do this? Let's try. 6 squared, what's that? 36 times 3? No way. 36 divided by 4, that's easier. 9 times 3? 27. So we got 27 plus what? 30 plus 12? 57 plus 12? 69, all right. And what are the units there? Centimeters per year? Just centimeters? Why just centimeters?
Here's how tall.
Because it's the original function and it's describing the height of the shrubs. So 69 centimeters, is that big? Went from being 12 centimeters to 69 centimeters over 6 years.
That's a half meter in growth.
They grow pretty slowly, huh?
I mean, I don't know why you're going to tall shrub.
I don't know why you would want that shrub. Maybe it's like
No, like a tall shrub.
a tall shrub. Yeah,
Isn't that
that's
basically
true.
a bush?
Wait,
Plus it says that they trim it, right?
Yes.
So they kind of force it to stay small. It's not nice. All it wants to do is grow.
Shrubs are people too.
Shrubs are people too. Alright, one more problem here. Okay, so it says a particle moves along the x-axis at a velocity of v of t is equal to 1 over the square root of t for time greater than 0. At time t equals 1, its position is 4.
What is it?
So what are they giving us here? A point, right? The point would be 1 what? 4, but that's on what?
P of t.
On p of t, on the position function, right? Okay. The first problem there, part A, says, what is the acceleration of the particle when t equals 9? Acceleration. So how do I find acceleration? Get the second derivative of position, but I don't have position. So I need the what derivative of velocity? The first derivative. Oh my God, do we know how to do that? No? We've been doing antiderivatives. We probably forgot about derivatives. How do I get the derivative of this guy? We know that this is t to the what power? Negative half. Okay, so what would we get?
Negative.
Negative 1 over 2
to the minus 3.
T to the negative 3 over 2?
Oh, you got
Plus
a
C?
minus 1, not add 1.
Let's see.
Oh.
Why?
There's no plus.
No plus C?
No.
Why not?
No.
It's a derivative, right? Very good. I'm just messing with your mind. Okay. So then they want me to evaluate it at 9. So before I do that, I probably want to rewrite it, right? So this is negative 1 over 2. And what root?
Cube root of t squared.
Cube root?
Oh no.
Where do roots
the
grow in
square
a plant bundle?
Square root of
On
t
the
cubed.
bottom, right? So the square root on the shrub. So the square root of t to the what? To the third. Okay, so be careful. All right, so now we want b prime at 9.
You see? Is that 81 times 9?
We can leave it like that, yes, but let's go a little bit further to practice. So do I want to raise 9 to the third,
Yeah.
or do I want to
Oh,
square
well,
root
we
it
gotta
first?
find the
What
square
would be
root of
easier?
7 to 9, so it's
You
just.
could actually decide which one to do first, it doesn't matter.
What would it be? 81 times 81.
I think it'd be easier to square root it, right? So what's the square root of 9?
3.
3, and then raise that to the third. So what's 3 to the third?
27.
Sorry, Sean.
That's
27 times 2.
Wait, why would you?
Negative 1 over